Determine whether the integral is convergent or divergent. Evaluate if convergent. The integral from negative infinity to 0, 2 to the r dr. Here we have an improper integral, which we can quickly see because we have an infinite limit of integration at negative infinity. So we're going to have to use the definition to evaluate this. This is going to be the limit as a approaches negative infinity, the integral from a to 0 of 2 to the r dr. The integral of 2 to the r dr is 1 over the natural log of 2 times 2 to the r. We evaluate that from a to 0. So first off, we substitute in the 0, the upper limit of integrations, 1 over the natural log of 2 times 2 to the 0 minus 1 over the natural log of 2 times 2 to the a. We put in the lower limit of integration, and now we evaluate this limit. 2 to the 0 is equal to 1, so in fact 1 over the natural log of 2, that's a constant, so when you take the limit, it simply goes to that constant, minus, all right, as a gets closer to negative infinity, now notice here that if I take the limit as a goes to negative infinity of 2 to the a, that's the same as if I take the limit as b goes to positive infinity of 2 to the negative b. That turns out to make things a little easier to visualize because the negative b is going to drop that into the denominator. Now b is going to positive infinity, so it's getting larger and larger. 2 to the b is an exponential function, so it also gets larger and larger and larger. 1 over that gets very, very small, so it gets closer to 0. So this limit goes to 0, so you could put in minus 0 there. And so our improper integral actually converges, and it converges to the value 1 over the natural log of 2. So we could conclude the integral from negative infinity to 0 of 2 to the r dr converges and is equal to 1 over the natural log of 2.